Hey guys, welcome back. We're going to forge ahead in Chapter 5. We're going to look at some more tissues today. Last time we went over epithelial tissues and we learned about simple and stratified and stuff like that. But now we're going to move to the connective tissues. And the connective tissues are pretty broad. There are lots of different functions of connective tissues. So unlike the epithelial tissues where they all covered surfaces, in some cases it was a protective surface, in some cases the surface was meant to absorb or secrete things. Here we have a really varied set of functions within the connective tissue category. So the first one let's hit here is areolar connective tissue, which is a type of loose connective tissue. Now you could go with either of these terms. Technically, areolar is one type of loose connective, but when we look at these images, first thing that strikes me here when I look at these are all of these dark lines. I see these dark purple lines throughout this big picture at the bottom, and I see some dark purple lines up here in this smaller image as well. And those dark purple lines are actually elastic fibers. So think of them like a bunch of rubber bands inside of a tissue. It makes this particular kind of tissue somewhat resilient, being able to stretch, okay, like a rubber band does. Now, we also see within this, particularly this image on the top, we see these pink fibers, okay? And these pink fibers are wider. They go all the way through here. They're kind of wider. And these are collagen fibers. Now, collagen comes in many forms, but collagen is actually the most abundant protein that we have in the human body. So we basically have elastic fibers and collagen fibers, and you definitely can find your nuclei, right? So your nuclei are kind of here in purple. And the big thing about a connective tissue, in this case, it is not covering a surface. There is no place where this particular connective tissue stops and then there's space next to it. This is usually not going to be out on the surface. It's oftentimes underneath surfaces, underneath epithelial tissues. For example, areolar connective tissue happens to lie underneath the skin. And it gives your skin that kind of flexibility. Okay, the actual epithelial tissue gives it strength, but then that flexibility, that resilience, is partly due to this areolar connective tissue. You also find areolar connective tissue in the gut, and a lot of the cells of the areolar connective tissue are going to be playing immune functions in the body. All right, so immunity and some protection gives you some resilience as well. And locations, we find this under the skin, and we find it in the gut and around organs within the abdomen and the thoracic cavity, all right? So that's our loose connective tissue. Now, let's say if we were to come along and what would happen if we took out all of the elastic fibers and put a big cinder block on this tissue, right? If it was under some pressure and it was squashed down, and we still had those pink collagen fibers in there, if we did that, you might get something like this, all right? So here we have a whole lot of pink, and I see my nuclei of my cells in here, but the nuclei, we'll use blue here for the nuclei. The nuclei are kind of squashed down, kind of like there's not a lot of room for them, and they're just kind of squashed between all of these pink fibers. Now, does this make sense if we think about the name of this? Dense, regular connective tissue. Let's just take the word dense. In the previous image, the loose connective tissue, these pink collagen fibers, these are collagen fibers just like they were before. These are all densely arranged, packed right together, dense regular connective tissue. Now, in the case of areolar connective tissue, it's kind of a loose arrangement. It gives you this flexibility back and forth. And there's a lot of elastic fibers there. But in the case of the dense regular connective tissue, there's fewer elastic fibers and the collagen fibers are real tight, and this makes for a really resilient, strong connective tissue called dense regular. And we see here in our image over on the left side here that this would be what makes up tendons and ligaments. So these connect bone to bone and muscle to bone, like your Achilles tendon, like you see in that picture there. Or if you take in your hand, you move your fingers around and you feel all these little sinewy kind of strings that almost are in your wrist here, and those are attached to muscles down below in your forearm. Well, those are all going to be tendons that are connecting muscles to the bones up in your hands. Okay. The reason we call them dense regular is because they are going one direction. So take, for example, when you stand up on your tiptoes, okay, or on the balls of your feet, what's going to happen is there's going to be this muscle here in your calf that's pulling on the bones in your heel, and the tendons here have to be strong in one direction. So all of these fibers are going to run in that direction. Thus, why you see this kind of wavy appearance of the dense regular. These are tissues that have been removed from the body. They're no longer under strain. And so you see that they've kind of taken on kind of a wavy appearance here. At one time, there was a connection on this end, and there was a connection on this end, bone to bone or muscle to bone. And this is why it has this regular appearance, kind of a wavy appearance in one direction. Down below, we again see kind of a wavy appearance going across, and we again see our nuclei that are kind of squashed in between those collagen fibers. All right? So these attach bones to bones and bones to muscles, locations, tendons, and ligaments. All right, now let's take off of this dense regular and think about what would happen if there was not just one direction of these fibers. What if we had a need for strength in many directions? Okay, this is where we'd get to the dense irregular connective tissue. So a part of the strength of the skin, in fact, is not just about the outside covering surface, the epithelium, but also about the dermis of the skin that we're going to talk about later. Just under the epidermis, this is where we have our stratified squamous, we're going to have an area underneath this that doesn't just have areolar connective tissue, which gives you kind of a stretchy, kind of flexible characteristic to the skin, but we also have a dense irregular connective tissue. So now we have it's almost like these are the tendons and ligaments underneath your skin, but they're not really tendons and ligaments. They're not providing strength from one bone to another or from bone to a muscle. They're providing strength, as you can clearly see, strength going in this direction, strength going in this kind of a direction. All of these fibers, all of these collagen fibers seem to be going every which way, thereby making kind of a dense, thick, strong connective tissue that adds to the strength of your skin. Okay? So this is going to withstand tension in many directions. This is a strong sheet-like connective tissue. Where we find this, lower layers of the skin, which we refer to as the dermis, and we'll talk about the dermis very soon when we get into our discussion on the skin in the next chapter. Okay? All right. So now let's move into the adipose connective tissue. Now, for adipose connective tissue, this is kind of a tricky one, because when we look at adipose tissue, this is actually fat tissue, okay? And they show you one area here which may be in mammary tissue and breast tissue, I should say. But you know, you can find fat in other places, right? You can find fat underneath the skin almost anywhere you look. You can find fat around organs. You can find fat in the abdomen, obviously, or your butt, or whatever, right? Now, the tricky thing here is, though, when I look at a slide of adipose tissue, I see blank space. And this, because it's white here, it doesn't really show up as being anything. And this might mislead. It might lead you to believe there's some air there, or that this is actually a surface on the inside here, but it's not, okay? With adipose tissue, these spaces, each of these spaces, is actually a filled up compartment of a cell, and it's filled with lipids, okay? So adipose connective tissue is absolutely synonymous with fat tissue, and these are going to be filled right up with lipids. So we can't start thinking that these are surfaces here along the way. The other thing we see here are the nuclei. So the nuclei are kind of pushed off to the side, and we see a nucleus every here and then, right? Every now and then we see a nucleus kind of pushed off to the side, and each of these nuclei will belong to a cell, right, to a big void of lipids next to it. So an example, let's find a good one here. So this right here, that nucleus, it looks like it might belong to, keep doing that. This cell here as we go around the outside. Okay? So imagine a nucleus, and then you've got this big cell like this. And then inside of that cell, we have a big fat vacuole, a big compartment, a membranous compartment that's filled with fat. Okay? Now, I always think when we look at these that they look like bubbles. You know how bubbles, when they come together, they'll be flat in between where the two bubbles touch. And that's what you kind of see here, is that it's kind of flat in between the cells. Okay. Other people, when they look at these, they think they look like marshmallows in a bag, like they're all squashed together in the bag and they're flat where they're pushed together. Or styrofoam. Some people think the kinds of styrofoam with the little particles, little white particles, kind of look flat where they're touching. Okay. Where would we say, what is a function? We'd say energy storage, because there are fats in there, right? Lipids are going to be about energy storage. But there's also a characteristic of insulation. It's going to protect and absorb, it's going to give some cushioning around organs. Locations under the skin, we've got a good amount under the skin and around organs in our body. And if you were to say, breast tissue or something like that, that would also be true. Okay, next one. Hyaline cartilage is a form of connective tissue. And hyaline cartilage happen to form the rings, the hard, kind of rigid cartilage rings in your neck here, around your windpipe. Now on the inside of that, of course, we have the trachea, right? But on the outside of the trachea, we have these rings that hold that air pipe open. Now, hyaline cartilage, I always thought, and part of the name, I believe, means glassy, okay? So I always think of this region here where we have kind of a diffuse kind of coloring. That is the color of the dye they used here, okay? And we see in between though there, we see that there are cells. How do we know that? Well, I see a couple cells here because clear as day you can see the nuclei inside those two cells, okay? Again, here we have another cell. So within this kind of glassy stained glass appearance, this kind of purple pinkish color, we have these little pockets where the cells are living. And this is a hallmark of cartilage. All cartilage have these little pockets. They call them lacunae. It's a funky word. We're gonna run into it again later, but these are little locations, little rooms where the cells live, okay? And again, we see that down below, okay, for this image. Here we see a little pocket of 3 different cells, okay? And then we see the stained glass appearance outside of that, and that stained glass appearance is a purple color because they used a purple stain, okay? So if you see kind of a stained glass appearance with little pockets where the cells live, hyaline cartilage. What is this all about? Well, this gives support, like these cartilage rings give support to our airways, okay? Where do we find it? Around our trachea. Not on the inside of the trachea. On the inside, remember, we have that pseudostratified epithelium on the inside surface. But here we're talking about the rings themselves around the trachea. Your nose, right, the flexible part of your nose, your larynx, which is your voice box, these are all structures made out of hyaline cartilage. And just a little trivia here, we'll find this later when we get into the bones. A good part of your skeleton in the womb as you're developing, as a baby that's developing, is hyaline cartilage. So you don't even have bone here. When you're starting off, you have cartilage shafts, and so hyaline cartilage also will make up the skeleton early on in life. All right, so look familiar here? Can you see pockets where cells are living? I can. I can see a pocket here. How do I know it's a cell? Because I see my nucleus. Clear as day, I see a nucleus here. There must be a cell there, right? And we can see these all over the place. So I see one there and there. I see a couple right next door to one another here, right? So here's a couple. All right. So this looks very much like the cartilage we saw before. Absolutely, this is a cartilage. We can see the same stuff going on down here, right? But in the area between the cells, it's not just a hazy stained glass look. In this area, what I see, I'll go to yellow here for this, are these little lines. I see all of these lines. Check out that one. That's pretty thick. There's another one. Here's another one, right? All of these lines are more of that elastic fiber. The elastic fibers that are in the areolar tissue that give the stretch. Well, here we've got a flexibility added to this cartilage because of these elastic fibers. So we say elastic cartilage rather than hyaline cartilage. It doesn't look as glassy. It has these fibers that give flexibility. This maintains shape and adds flexibility. Classic example, the cartilage is in your ear. Okay, you can bend that right down, flips right back up. Okay, it's not as rigid as the flexible hyaline cartilage in your nose or in the trachea or in your larynx, your voice box. Another place you have elastic cartilage actually is the epiglottis. I don't know if you guys have heard of epiglottis, but that's basically covering your airway, so when you swallow you don't have food go down the wrong way. But the ear is a really classic one, easy one to remember. All right, there's one other cartilage that we're going to run into, but we'll leave that until the bones when we get to the skeletal system. We only have, for this section, 2 more that I want to go over with you, and we're done with our connective tissues, okay? So this next one is a clear giveaway because nothing else looks like this. This is going to be osseous or bone tissue. All right, so we're talking tissues here. We're not talking about the whole bone. We're going to learn that a bone is actually an organ with lots of tissues in it. But certainly we would expect there to be a tissue in there, and that bone tissue could be called bone tissue or osseous tissue. So here we see a bone. This is actually the upper arm bone, the humerus bone. This is one that you'll have in your lab list that you're going to have to learn the name of that bone. Okay. But if we were to take a cross section of that bone right there, my humerus bone, you would find that there were various cylinders of structures, and this is a cross section of one of those cylinders. You can see this big cross. This is a cross section of what we would find if we cut through that humerus bone. Down here, again, you can see these kind of cylindrical structures. Okay, keep in mind, this is if we cut across the bone like this. Okay, if we cut across the bone like this, we're going to have these cylindrical structures. So this is, if we were to follow these rings would come out of the screen at you, right, and into the screen, into your computer screen. So these are actually long columns, long cylinders that give strength to the shaft of your bone. Okay, and you can actually see the nuclei. Bone is a living tissue. Okay, it's not just this hard calcium. People think of it like a bone, like a rock. Okay, there's actually some flexibility to bones, and we can see here. I'm just in yellow. I'm just tracing where we see a lot of cells, living cells, until they sliced this and plopped it on a glass slide for us to see in a light microscope. These were living, breathing cells, okay, that are stuck in the matrix of this bone tissue, and you can see them down here too, right? All right, so some of this stuff is kind of a no-brainer. Don't let the new vocabulary mess with you. Okay, granted, probably a lot of you didn't know anything about hyaline cartilage. You might have heard of cartilage, but what about hyaline cartilage? Maybe you hadn't heard about areolar connective tissue, right? Something crazy like that. But bone, if I were to ask you where is bone tissue, I mean, duh, right? It's going to be in our bones, okay? It's going to be for support and protection. It moves our body around, right? This is giving us our body the support it needs, and in some places the protection it needs, right? Like the bone that is my skull, right? To protect my brain, my rib cage, protecting my heart and my lungs, right? So don't let it fool you, right? That some of the answers to the question, if I were to say, where do we find osseous tissue or bone tissue? Well, absolutely, bones in your skeleton. Okay. Last but not least, among our connective tissues, we have a rather interesting and a unique one, the blood. Okay, the blood, believe it or not, is a connective tissue. However, it is a liquid form, right? We have the plasma of the blood, which is the extracellular fluid outside of our red blood cells. In this particular case, we have to recognize the fact that the white space all through here is actually not white space. It's actually a fluid, the plasma of the blood. So if we shine light through a very thin sample of blood, well, that thin sample of blood, the light's going to go right through the liquid part super easy. It's like it's not even there, okay? So it's going to look white in a light microscope. Here it's not quite exactly white, but it's very pale, okay? So we have to keep in mind that this really is not space. This isn't air. This is actually a tissue with liquids out here. And the other thing that's unique about this is that our red blood cells, so each of these is a red blood cell, do not have nuclei. All of our other tissues, we could find nuclei, pockets where they were in the cartilage. We found them kind of stuck in the bone. We found them kind of scattered throughout areolar tissue and even squashed in between fibers of the dense connective tissue. Here, we see some nuclei. I'll use purple for this over here, so I have a nice kind of an S-shaped, weird-looking nucleus over here. And that is part of a white blood cell. This is our white blood cell here. Kind of barely see the outside boundary. But our other cells here, our red blood cells, do not have nuclei. So this is kind of unique that cells do not have a nucleus. This is not to mean that they don't start with a nucleus. In fact, they do. But when red blood cells, like you see down here, down in the lower image, when these are out circulating through your body, they do not have a nucleus. Now, occasionally you'll see these little tiny pieces around, like you see here. Those are little platelets. Now, I'm not going to get carried away with all of the structures, white versus red versus platelets. For our purposes here, just a reminder, I would want to know to be able to name this by sight. So when I see this, I want to be able to say that's blood. I want it to have a function. In this case, blood is going to transport things around the body, namely gases like oxygen and CO2, waste products, nutrients like blood sugar, and other things. So there's a transport function to blood. And the last one, again, don't let what you already know coming into the class be pushed out by all the other information we're learning. The fact is, you know where blood is, right? It's in the blood vessels. It's in our circulation, okay? And that is absolutely still true. All right, so I think I'm going to leave it at that. Epithelial tissues were kind of a long clip. This one was too, but our last couple here with muscles and nervous system, much shorter. It just so happens that epithelial and connective tissues are a rather large group to get down. So I'll see you guys again next time with our last few tissues.